morning, my dear students. Welcome to this digital chemistry class. As you know that we are doing nowadays the chapter equilibrium, where we have studied that equilibrium is the whole chapter is divided into two parts, in which first part is chemical equilibrium and this is the second part, that is ionic equilibrium. So ionic equilibrium is also known as electrolytes. So in this particular section we will study about the electrolytes, what is electrolytes, what are the classification, that is strong electrolytes, weak electrolytes, what do you mean by non-electrolytes, then the theories basically, which is acid and base, Rnas concept, and Bronsted-Lowry and Lewis acid base. Okay, so let's start first from ionic equilibrium. So what is electrolytes? This is the first question, dear students. What is electrolytes? So electrolytes are the substances like acid, base and salt which can conduct electricity in their aqueous solution due to ionization are called electrolytes. Very simple. These are those substances which conduct electricity in their aqueous solution due to ionization. And the presence of ion solution is responsible for the conduction, and when the current passes through the wire, it shows the movement of free electrons through wire. This process of dissociation and flow of electron in the aqueous solution of electrolyte is called electrolysis. For example, electrolysis of sodium chloride in its aqueous solution gives sodium and chloride ion. Okay, for example, in any battery, for example, in any case where any salt, suppose NaCl is salt and it breaks down into two ion, that is Na plus Cl. Na ion is called cation and Cl negative ion is called anion. So cation and anion are the ionic compound and ionic form of the compound. So next is if we will see, so there are basically so many type of electrolytes which is present in our body also, such as sodium, magnesium, calcium, potassium, chloride ion and bicarbonate ion. These electrolytes involved in the various function of our body cells and organ also, whereas each ion has its own role and the body movement is a result of the function of these ion. So dear students, it means that electrolytes are somewhere very important. Some of the example of electrolytes are hydrochloric acid, nitric acid, sulfuric acid, hydrobromic acid, hydroiodic acid, perchloric acid, acetic acid, carbonic acid, ammonia, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cerium hydroxide, calcium hydroxide, strontium hydroxide and barium hydroxide. So these all are the example of general electrolytes, but up to this, these are acidic electrolytes, and below this these are basic electrolytes. It means that all substance which produce H positive is called acidic, and all the substance which have OH negative ion, you can see in the end OH is the common, so that is called basic electrolytes. Okay, so now when you know there are two types of electrolytes, strong electrolytes and weak electrolytes. Strong electrolytes are those electrolytes which such as potassium chloride, sodium hydroxide, sodium nitrite, which is completely ionized as the constituent ion in the solution. These electrolytes are known as strong electrolytes. In other words, strong electrolytes are 100% dissociated. Okay, suppose KCl convert into K positive Cl negative, NH4NO3 will convert into NH4 NO3 negative, HNO3 H positive NO3 negative, NaOH Na positive and OH negative. So now if we will take this example, so here you can say pictorial example, nitric acid, it means that HNO3. So this small gray so is H, blue dot is O and yellow is oxygen. So it will convert into H positive and NO3 negative, whereas sodium chloride, green is sodium and yellow or blue is chloride, so it will positive and negative charge. So like this way, strong electrolytes like salt are composed to oppositely charged ion. In solid state, these ions are held by strong electrostatic force. Okay, if molten state is there, that time it will convert into positive and negative charge cation and anion. But when it is solid state, so it means that the ions are held strongly with electrostatic force. When these electrolytes are dissolved in water, the attraction force between ions are highly weakened due to the high dielectric constant of water. So there are some list of strong electrolytes: chloric acid, sulfuric acid, hydroiodic acid, hydrobromic acid, hydrochloric acid, sulfuric acid, nitric acid. These are some example of strong electrolytes. Similar way, we have weak electrolytes. Weak electrolytes are those electrolytes which is weakly ionized and the solutions are not dissociated completely. In this aqueous solution of weak electrolyte, the constituent ions are the equilibrium with undissociated molecule of high electrolytes. Due to partial dissociation of electrolytes, the number of ions in the given volume of the solution is almost same. So basically CH3COOH will break down into H3O positive plus CH3COO negative. So the pictorial diagram is there. Such type of equilibrium exists between ions and unionized molecule, which is called ionic equilibrium. The fraction of molecule dissociated can be represented by using degree of dissociation. Generally, weak acid and base are good example of weak electrolytes. Okay, so these are the list of weak electrolytes: acetic acid, hydrocyanic acid, ammonium hydroxide, ammonia, hydrofluoric, carbonic acid, mercuric acid, chromic acid, and boric acid. So dear students, these example just take the screenshot and write down in notebook and do learn. Okay, sometime 1 marks question it is coming. Non-electrolytes, those solution which cannot conduct electricity in their aqueous solution due to the absence of ions. They are generally polar and non-polar covalent compound which can dissolve in water as molecule instead of ion. As covalent compound contain covalent bonds between bonded atom, therefore cannot be ionized in their solution, and it exists in the form of molecule only. Okay, so for example, sugar solution are non-electrolytes. There are some example of non-electrolyte. These are basically organic: sucrose, glucose, ethanol, methanol, carbon tetrachloride, carbon disulfide, kerosene, chemical pure water, urea, dichloromethane, glycerol. These are all the example of non-electrolytes. Now next, Arrhenius concept of acid and base. In 1884, the Swedish chemist Svante August Arrhenius, he was also awarded the Nobel Prize in Chemistry for proposing that ionic compound can divide into oppositely charged particle of solution. So he proposed that acid and bases can be defined as the chemical species they form when they dissolve in water. So Arrhenius acid is what? All those substances which after ionized give H positive or H3O positive, that is known as acid. Okay, H3O positive, which is giving H3O positive after dissociation with water, is known as Arrhenius acid. For example, here example, if I'll case CH3COOH plus H2O will break down into H3O positive plus CH3COO negative. Okay, so this is the one example. Then Arrhenius, in the case of HCl, act as Arrhenius acid in the water. It convert the chlorine negative ion, sometimes H3 positive, and it is given negative charges. When Arrhenius acid are in pure water, they are covalent compound, that is they do not contain H positive ion. The ions are formed through the interaction between water and the acid when they are mixed. Okay, so ionization is the process in which individual positive and negative ions are produced from the molecular compound that is dissolved in solution. If I'll talk Rnas base, there is strength of Rnas. Okay, so it means that on the basis of Rnas, acid can be strong acid, weak acid. So again, take screenshot and just read these acids which completely ionize and give maximum number of H positive. Their value of dissociation is more and they are known as strong acid, represented with key Ka, mean the strong acid which is very high, the strength of acid directly proportional to the dissociation constant. This Ka is called dissociation constant of acid. HCl, HNO3, H2SO4 is the strong acid example. Weak acid, those acid which are partially ionized in solution, like acetic acid, hydrofluoric acid, hydric acid. These are dissociatively very less and are weak, dissociating constant value. Okay, so acetic acid, protonic acid, and phosphoric acid are the example. Now similar way, there is a some example, so just take screenshot. More the constant value, more the dissociation constant value, more will be the stronger acid. These are medium and these are lowest, weakest. Okay, so now next is Rnas base, and Rnas base is a hydroxide containing compound that produces hydroxide ion, OH negative ion. The basic species in Rnas tissue theory is thus the hydroxide ion. It means that Rnas acid are those compound which give H positive and H3O negative, H3O positive, and Rnas base are those which is giving us OH negative ion. So you can see here all these example where KOH break down into K positive and OH negative ion, OH negative ion. It means that these are Rnas base. So like Rnas acid, Rnas base is also strong and weak. All those substances which dissolve in water and dissociated and completely dissociate with OH, that is called strong base. The value of base dissociated to constant and strong base is very high. That's so Ka is suppose dissociation constant of acid. Similar way Kb is the dissociation constant of base. So NaOH is KOH is the example. Weak base, those bases which are partially ionized into solution and giving very less number of OH negative ion. So NH4, OH, Ca, OH2 are the example of weak base. So these are the some weak bases: ammonia, aniline, codeine. So take example, screenshot and make it. Okay. But dear students, there is a very good contribution of RNAs. Similar way, there is some limitations of RNAs also. The first limitation is this concept couldn't explain acidic and basic character of certain substances like NH3, Na2, CO3 and CaO, which is basic. CO2, SO2, SO3 are acidic, which do not contain H positive and OH negative. Second, it couldn't explain the reaction between an acid and base in the absence of water. These are the limitation of RNA's equation. Next is the Bronsted-Lowry acid and bases. In 1923, J.N. Bronsted and T.M. Lowry, two scientists were there, independently developed the theory of proton donor and proton acceptor. As Rnas acid base is, suppose Rnas acid is H positive and base is OH negative ion particles. Similar way, Bronsted-Lowry is proton donor and proton acceptor. Proton donor and acceptor in acid base reaction is coincidentally same region of the during the same year. The main effect of Bronsted-Lowry definition is it identify proton transfer occurring in the acid base. This is best illustrated like this way. Mean where acid are those which is donating hydrogen ion. Acid are those which donating hydrogen ion, and base which accept hydrogen ion. It means that proton donor is called acid and proton acceptor is called base. Here HCl donate H and H2O will gain H. So this is the simple definition of Bronsted-Lowry, in which acid is what? An acid is defined as a substance which has a tendency to give a proton. An acid is a proton donor. Very simple. A base is defined as the substance which has tendency to accept a proton. So base is a proton acceptor. So when HCl will react with H2O, it will give H2O positive, Cl negative, NH3 plus H2O, NH4 positive, OH negative, HCl plus NH3, NH4 positive, Cl negative. Sometime question is coming, what is the best pair of acidic pair of the HCl? So you should know H2, H3O positive. Okay, important result is what? HCl is an acid because it donates the proton to water, and NH3 in second. NH3 is base because it accepts the proton from water and HCl. Water act as both acid as well as base, so it is called amphoteric. This is again acid act as acid as well as base, so it's called amphoteric. Okay. Next question. If I will say next question, so very next question, next slide is to determine whether a substance is acid or base, we need to count hydrogen on each substance before and after the reaction. If the number of hydrogen has decreased, the substance is acid, donate hydrogen ion. If the number of hydrogen has increased, the base is accept hydrogen ion. These definitions are normally applied to the reactant on the left. If the reaction is viewed reverse, a new acid and base can be identified. The substance on the right side of the equation are called conjugated acid or conjugated base. So it means that we can study conjugated acid and base also under Bronsted-Lowry equation. Okay. So I suppose HCO3 negative plus H2O, it will give H2SCO3. So it means that it is same reaction in the reverse also. These are conjugated acid base pair. Okay. So conjugated acid base pair need to understand very simply. So the conjugated acid base pair are compound differ by H positive ion. Conjugated acid is equal to conjugated base plus H positive ion. Similar conjugated base is conjugated acid plus OH negative ion. So here if you say HCl, its conjugated pair is base is Cl negative, acid is H3O positive. H2O plus NH3, NH3 positive is acid and OH negative is base. So these are the conjugated base pair of the conjugated pair 1. Advantages are there. It is not limited to molecule but include even the ionic species act as acid and base. It doesn't require aqueous medium and explain acidic and basic nature. It can explain the basic nature of ion and molecule having number of OH negative ion. Whereas some limitations are also there. It couldn't explain the acidic and basic nature on the compound having no tendency to lose or gain H positive ion. For example, carbon dioxide, ammonia, SO2, SO3. It couldn't explain the basic nature of compound which have OH negative ion, NaOH, COOH and KOH. Suppose so. Lewis acid and base are the third basic definition of acid and base. It is an important way in which scientific knowledge advances and modify the In 1923, G. N. Lewis proposed a broader concept of acid and base. The concept eliminated with the necessity of presence of hydrogen in acid and including many more substances in acid and base. According to this concept, an acid is an electron pair acceptor and base is the electron donor acceptor. Okay, so as RNase is in RNase acid is those who are H positive, base are those who are OH negative. In case of Bronsted-Lowry, all are acid which is proton donor, all bases are proton acceptor. Whereas in case of Lewis acid, all are acid which accept a pair of electron, and all the base which is donating one pair of electron. So Lewis acid are there which is electron pair acceptor. The acceptor electron pair is shared between the acid and base are covalent bond. Thus Lewis definition of acidic just it included many species in addition of H positive. This one, for example, various metal like cation such as magnesium and metal compounds such as aluminum chloride and Lewis acid because they have unfilled valence orbital and can accept electron pair. So types of Lewis acid: molecule have central atom of incomplete octet. Simple cation is also example. Molecule containing multiple bond is also example. Whereas strength on the basis of Lewis acid are very important for explaining the interaction of different metal ion with specific interaction partner within toxified cells. The Lewis acid strengthen the metal ion is said to be proportional to the generalized electronegativity. Suppose these are the three type. Lewis acid are three type: hard acid, moderate acid and soft acid. Hard acid are these: H positive, lithium positive, sodium positive. Okay, suppose for particular metal. Moderate acid are generally transition element and soft acid are also the transition element. So next after this, Lewis base, the substance that donate the electron pair, and it is donating electron pair which is shared between the acid and base. If more general sense, most oxygen and nitrogen containing organic compound, neutral molecule and negatively ion charged are Lewis base. NH3 are Lewis base, halogen group is Lewis base. Okay, after this, list of Lewis bases are these. Once you just take screenshot and just learn. Strength of Lewis base is correlated well with other measure of basicity, such as with phosphorus. They are given for a variety of anion in the adjacent table. So this is not that many. So now there is some limitation of Lewis concept also. The necessary requirement of Lewis concept is formation of a coordinate bond between the acid and base. Similarly, the catalytic activity of an acid is due to H positive ion, since the presence of hydrogen is not an essential required for a Lewis acid. Many Lewis acid will not have this property. Okay, so these take screenshot and again write the notes. So this is all about for today, dear students. Hope so you understood. Today we did about electrolytes, definition, different types of electrolytes and different theories of acid and base on the basis of electrolytes. So thanks for watching. Thank you very much. Have a nice day. Take care. Stay home. Stay safe.